whenever we start a proof, we always need to write proof. Start by writing proof. Proof. Dot, dot. In triangle, and remember they've given us information that we must read. In triangle ACD and triangle ABD. Okay, and then for congruency, we need 3 reasons. 1, 2, 3, and that will help us prove for congruency. Okay, have a look at this question and see what we've got over here on the screen and how it can help us. Hi, Jasmine. Oh my goodness, I get to see your pretty face today. Hello, I've never seen your face before. Hi. Okay, do you wanna answer this question for us? Have you got an idea where we're going to go? Or do you have a question?
No, I do not want to answer the question, but
okay.
I got my results back today for the exam.
Yes. And
I just scraped pass.
You know what? We're gonna celebrate that because it's a pass. And I'm very proud of you. I'm very, very proud. I think grade 10 is like a big adjustment, especially in term 1. But I know you're here with us every single day, Jasmine. Well done.
Thank you.
Even if we just scrape past, a pass is a pass. Okay, well done. I'm so proud of you. Okay, now we just need to work on getting those just slowly climbing, and we will slowly climb. I just feel like term 1 is a big adjustment for everybody, but I'm so proud of you. Very well done, Jasmine.
Thank you.
Very, 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 very well done. Hello, guys. I see Lopen is back with us. Hato, David is here, Liabona is here, Tiana's here, and Samuel. Hi, guys. Have a look at the question we've done on the screen. Congratulate Jasmine in the chat for passing term 1. I'm so happy, so proud of her. If you guys also got your reports back, please let me know how you guys did so we can celebrate with you. A pass is a pass. If your marks are improving even by 2%, we're happy. We're so happy. All right, guys, have a look at the question on the screen. All right, I'm going to give it 1 more minute. Make sure you guys are understanding the question. Read the question that they've given us. Okay, triangle ABC is in a circle with center A, B, and C are on the circumference. Prove that triangle ACD is congruent to triangle ABD. Okay. If anybody's got any idea how to solve this question and would like to help the rest of the class out, please make sure you put your hand up, okay, and tell us what you would do to prove congruency. Tell us, tell us. Anybody? Okay. Oh, Atahang is saying something, Tiana. I like it. Hi, Tiana. Atahang, you are 100% correct. We're going to take it from there. Hi, Tiana. What have you got? What have you got?
So I meant, so I wanted to say that AD is common.
Good. I'm going to put that as the last thing over here. AD is common because I agree with you. It is. It's common in both. 100%. Atahang also says AC is equal to AB. Do you know where you got that from? It's not given to us. But what is the reason? It's not a given. That's not the reason. Why can we say that AC is equal to AB? You know?
No, I don't know, man.
Okay. Remember I say that ABC is in a circle with center A. So if this is the circle center, what do we call any line that goes from the center to the center? What do we call this one? Okay, Atahang is 100% correct. Everybody else, give me your answers. What do we call a line that goes from the center of my circle to the circumference? That's it. iPhone, tell us what your name is so that we can change it for you. Good. So if both of these lines, if both AC and AB, if AC and AB both go from the center to the circumference, that means that they're equal because they're both radii. So we're not going to write radius. Oh, hi, Tiposetu. All right. We'll change your name for you just now. Teacher Hugo, if you could just help me out there. All right. So we can say that this is radii. Okay, excellent. Hatu, what's up?
Ma'am, I wanted to give like the second one.
Yes, absolutely. Tell me, what is the second reason?
Ma'am, angle ADC is equal to angle ADB.
Beautiful. Or in this case, because they've numbered the angles for us, we can just go angle
Oh, angle
D1.
one.
Angle
Okay,
D1 is equal to angle D2. What's
Angle
your reason?
D2.
What's your reason?
Ma'am, angles on a straight line or like perpendicular lines.
Good.
Which
You
one?
can even say because AD, you can say AD is perpendicular to CB because they told us that, or we can say angle on straight line. Okay.
Okay, ma'am.
Excellent. Beautiful. You don't go away. Come back. Okay, are you still here?
Yes, ma'am.
All right. Okay, we've proven congruency. Therefore, we can say that triangle ACD is
Is
congruent
congruent
to
to
triangle.
triangle ABD.
Right. Do you know the reason? What is my reason or my rule?
Ma'am, I really don't know. Side angle or angles. It's one angle and like two sides.
Yes, true. It's one angle and two
Is
sides.
it SAS?
No, it's not the same. Okay,
I
you
was like,
almost
not
there.
yes, like I don't know.
Okay. Think about it. Hi, Tiana. What do you think it's
That's
going to be?
SA.
No.
Ma'am, I don't have an answer. I have a question.
Yes.
So the first reason, okay, the first one. The reason they radius, I don't understand it. Like I've never did it before, so I don't understand.
This one here in the middle.
Yeah, depth of radius.
Oh, the one of radius. Okay, it's quite common. We're going to use it quite a lot, especially when you get to like grade 11, you're going to see it quite a lot. Okay, so we call it radii because we know that if anything goes from the circle center to the circumference, it's called a radius. Now I have two of them. One is called a radius, two is called radii. That's the only reason why I wrote I because I have two radiuses in okay. But if they both go from the center, even if I had another line, Tiana, that went from the center on this side, this one is also a radius. It's also equal to AC and AB because they go from the circle center to the outside of the circle, so they're the same. Okay.
Okay, thank you, ma'am.
You're very welcome. That's it. Amber got it. There we go, Amber. That's what I was looking for. I think you guys completely forgot. Tarika says, ma'am, why is CD not equal to BD? It is. They are equal, Tarika, but we had to prove that. In order for us to say that they're equal, we first have to show that everything else is the same. The only way we'd be able to say CD is equal to DB is if they had done this for us. If they had actually told us that they were equal, but they didn't tell us that they were equal. So we can't just assume that they are. We must prove it. Okay, we must prove it. But now that we've proved congruency, you can go ahead and say CD is equal to B. Yeah, I hope that makes sense. Okay, so Amber's got the right idea for those of you who are a bit lost. Okay, this is a right angled triangle, and this is a right angled triangle. Right. This side is common to both of my right angles, and this over here, because this is opposite my right angled triangle, it's a hypotenuse. It's a hypotenuse. So my reason for congruency in this case would be right angle. Okay. Tiposechi says, ma'am, why is it not SAS? Because remember, what did we say about SAS? SAS means the angle must be in between the two of them. So I have a side, and I have a side, and then I have a side, and I have a side. The only way I could use SAS is if the angle in the middle, the included angle, was the one that we have. But we don't have the included angle. We have the angle all the way here. Okay, so SAS only works if the angle is included in between my two lines. Okay, does that make sense? I hope that makes sense to you. All right. No gift. It's not going to be about triangles. It's just these two lessons, actually. Starting next week, Monday, we're going to start looking at quadrilaterals. Okay. Yeah, lie. And then we're going to go back to triangles again. I'm sorry, my dude. I'm sorry. All right. We're going to start with similarity today. Okay. And this is lesson 2 of 6. So for those of you joining us for the first time today, you've already kind of missed lesson 1. So if you're struggling on what just happened when we were proving congruency, please quickly after this lesson, go watch lesson 1, because that will explain a lot of what we were doing in that first. Okay. Yes, Bulelo, but remember, it's not like you have to do it right now. You don't have to do it right now. Okay. You have until next week, Monday, in fact, next week, Wednesday, to do it again, because the next quiz is only next week. What can you watch on our website? Exactly where you go to log into today, unless if you go to the website, you log in with your details, look for today's lesson. Right underneath today's lesson will be Monday's lesson. Okay. All right, we're going to be talking about similar triangles, guys. Okay, and I knew this would move as well. This is not what I was hoping for. All right, you can tell me, we have learned about congruent triangles, but what is the difference between similar triangles and congruent triangles? Who wants to venture a try as to what the difference is? Diana, what do you say? Yes.
So congruent triangles are like exactly the same. And then
Mhm.
similar triangles are like it's the same thing. It's like a smaller version of the bigger one.
Yes, good. Yes, it's a smaller version. But what do we have that's the same inside similar triangles? What is the same in all similar triangles?
The angles.
That's it. Yes, exactly. So if I've got this big triangle and the small one, they have the same angle over there, the same angle over here, same angle over there. Well done. That's exactly what I was looking for. Yeah. You mustn't doubt yourself. Yeah, no, you got this. You got this. All right. So in similar triangles, the angles are the same. Right. Good, Rita. Okay. That's what I was hoping to hear, but you've missed one thing. Okay. Similar triangles. When we look at similar triangles, only the angles are the same. Okay. And we're going to learn about something about the sides. All right. But in congruent triangles, everything is the same. The angles are the same. The sides are the same. The shape is everything is the same. Okay, in a congruent triangle. In a similar triangle or a similar shape, only the angles are equal. But what do we know about the size of a similar triangle? What we know, like Tiana said, that the one is just like a mini version of the other. So let's say, for instance, I said to you guys that this side over here, if I say that this big triangle is 2 times the size of this tiny one that we've got over here. If my side C over here is equal to 8, what is my side F going to be equal to? Different personality. No, people say to remember, the other one is the smaller version. Good. That's a Tanipolo, that's a David. Good. So if this one side of mine is equal to 8, this side is going to equal to 4. Okay. And if this side of mine over here is 10, what is E over here going to be? Good. It's going to be equal to 5. Same with this side over here. If this side is equal to 6, I know that my D over here is going to equal to 3. Yes, and teacher Hugo is like, so congruent triangles are more similar than similar triangles. Yes, that's it. That's it. So congruent triangles are like identical twins, and then similar triangles are like twins that don't look the same. You know what I mean? Non-identical. That kind. That's it. All right, good. So when we got these kinds of relations, guys, I can say that if this side is 8 in this triangle, it's the same as the side being 4 in this triangle, which is the same if this side is 10, it's the same as the side being 5 in this triangle. And if the side is 6, it's the same as the side being 3 in this triangle. Okay, so when we talk about the sides of similar triangles, we can say that the angles are equal. We can say that the angles are equal. And we say that the sides are in proportion. Okay, so there's some sort of ratio or proportion happening both of them. I'm going to ask you guys again. In similar triangles, the angles are what? What are the angles? The angles are? Tell me in the chat. The angles are? That's it, Zamanzini, good. My angles are equal, good. And the sides, in a similar triangle, the sides are what? Do not say equal, it's not equal. I'm giving you a hint. That's it, up keyword, good. My sides are in proportion. My sides are in proportion. Now, I hope you guys remember that Teacher Coco was being very, very, very stringent about us getting the order of triangles correct when we were doing congruency. And it's very important that we do, because we need to remember where they're sitting in terms of what's happening. So I've got this triangle called ABC. Okay. What this actually tells me is that the side over here, AB, that's the name of the side. The angle over here is called A. Okay. Now I can also say that the side opposite to A is called small letter a. This is angle B, and the side opposite angle B is small letter b. And if this is angle C over here, that means the side opposite to angle C is going to be small letter c. So we can differentiate between an angle and a side using capital letters and small letters. It's very important that we remember that. We can also call the side C, but we can also call it AB. So side AB and side C means the same thing. We mean the same thing. Now, I want to ask you guys, if this side over here is called D, what is this angle opposite it? What is this angle over here going to be called? In the chat. That's it. Oh, I love how you all use capital letters. That's it. That's what I was looking for. Capital letter D with a capital T on it. All right. If this side over here is F, that tells me that this side over here is going to be capital letter F. Okay. And if this side over here is E, that means the opposite angle over there is going to be capital letter E. That's it. Good. Now, that stands to reason that the side F can also be named ED. It's the same side. ED is also named F because of the angle on the opposite side. Okay, so F and ED, same. The same over here. This side D can also be called EF. That's just something that we're going to remember for now. But remember, the sides are in proportion in accordance to where they're sitting in our triangle. So now I'm going to ask you guys, if this, I'm looking at triangle ABC, and I want you guys to compare it to triangle EFD. Side AB corresponds with which side in the other triangle? Can you guys tell me? Side AB will correspond with which side? Oh, Handrikolo, David, Mnamani, I hope I'm saying that correctly. Mnamani, Zamanzini Tato, Rita, 100%. it corresponds with side EF, or if you wanted to, you could call it side small d. Same thing. All right. Then it says angle A. Angle A corresponds with which angle, guys? Which angle does angle A correspond with? That's it, Loken. Well done. It corresponds with angle E. This one up here. Okay. Cool. What about side BC? Which side does BC correspond with? Good, excellent. It corresponds with side FD, or if you wanted to, you could call it side E. That's it, Liabona. Well done. Or we can call it side E. And my last question is angle C corresponds with angle what? Ogute, you're on fire. Well done. That's it. It corresponds with angle D. All right, this is easy stuff. We're looking at it from an easy perspective here. There's nothing new that I'm teaching you guys. You're probably all like, Coco, we know this stuff. All right, but I need to remind you guys that the order is very, very important. The order in which we write these are very important. Okay, so I need you guys to remember, when we were doing congruent triangles, I made sure that you guys map out the triangles in the order that you need for them. So if I said to you guys that I want to know triangle ABC is similar to triangle, okay, which triangle is triangle ABC similar to? And remember, similar is like 1, 2, 3 lines in this direction. Which triangle is it similar to? What do we call this other triangle that it's similar to? What would we call it? Ah, that's it. Good. Okay. Oh, hold on. And I knew somebody would make this mistake. Zvulelo. Okay. Remember, the sides need to correspond. And I'm going to explain this. All right. When I say triangle ABC, I started at A, and then I went to B, and then I went to C up. Okay. That means that when I map my smaller triangle, I need to start with the corresponding side to that. I need to start at E, go to F, go to D, and then close off my triangle. So I need to do it in that order. So if I went triangle A, B, C, that triangle will be similar to triangle E, F, D. We need it in the correct order because the sides in proportion should match up. So what this is actually telling me is that side AB will be in some sort of proportion to side EF, as you guys had said. And that will show in my triangle because triangle AB or the side AB will be proportional to EF. The first 2 letters in this triangle will be in proportion to the first 2 letters in the other triangle. Same with, if I asked you guys, side BC, which side is BC? Which side does it correspond to, guys, in the other triangle? Good, that's it, Siposetu. BC will correspond to side FD. And our triangle, and the way we've written our triangle will reflect that. And then we can go all the way to the end. We can go side AC. Which side will AC correspond to? The side? Have a look, guys. AC will correspond to EB. Excellent. Wow, 100%. You guys are getting it. Okay, so the order matters. What happens, guys, if I say this? If I go triangle CBA is similar to what? Which triangle is CBA similar to? Now, remember the order that I moved in. Look at the order that I moved in my triangle. Good. I started at C, and then I went to B, and then I went to A, close triangle. So what I need to do is start at D on this side, start over here, go that way, and then up. So triangle CBA will be similar to triangle DFE. Okay, in that order, because when we have to compare sides, my triangle needs to be able to reflect that. If I compare sides, my side CB will be in proportion to my side B. Okay, so it's very important that we're doing that, and you guys are doing excellently. Just 100%, you guys have got this. All right, let's talk about these angles being in proportion as well as the angles being equal and the sides being in proportion. We're going to look at these triangles that they've given us over here. They're all in some proportion. Okay, we're going to answer these questions over here. It says, if in the triangles above, if A is equal to 84 degrees, and B is equal to 38 degrees, calculate the value of all the other sides in the triangle. Now, obviously, we know that C is missing. But before we even get to C, if A, remember this triangle, I'm going to pull this triangle and I'm going to map it in this order, A, B, C. If this is triangle A, B, C, what does this triangle have to be, guys? Triangle what? Tell me about this one and tell me about that one. Give me the order. Give me the order. Good. Let me see where. Small letter or capital letters? We just spoke about this, guys. Come on. We just spoke about this. Good. It's going to be MNO, triangle MNO, and the other will be QRS. Good. In that order. Excellent stuff, guys. Awesome. All right. So now we know which side corresponds with which. Angle A will be the same as which other angle, guys? Angle A is the same as, give me two other angles that angle A is equal to. M, that's it, Liabona. And what else? Ah, that's it, Gift. And Q. So we can go ahead in this and we can say that angle A is the same as angle M. So angle M will be equal to 84 degrees as well. And angle Q will also be equal to 84 degrees. If angle B is equal to 38 degrees, what is angle N equal to? That's it, Zamanzini, good. N and R are also going to be equal to 38 degrees. Good, 38 degrees, 38 degrees. I want you guys to tell me what is angle C equal to. I know you guys can all figure it out. We know how to do this. We know how to do this. You can tell me what angle C is equal to. Ah, that's it. Beautiful. Have angles in a triangle. Okay, good. Because of angles in a triangle. 58 degrees. Good. It's not rocket science, guys. It's never going to be rocket science. Okay. Good. All right. So those are our angles, and our angles are equal. We know this. Angles are equal. Let's talk about these sides in proportion. Right. We're going to take this at face value at first, but we are going to have to do some sort of calculation. So I want us to, for now, we're going to ignore our big triangle. We're going to work in these two triangles. So I'm going to say in the correct order, in triangle ABC and triangle MNO. Okay, we're taking them in the correct order. We know that there's some sort of proportion that's happening. If this side over here is 4, if BC is equal to 4, and NO is equal to 4, what is the factor? This one is the mini one. How much have we expanded MNO by to get that big one? No, they're not. Remember, the interior angles of a triangle are going to give us 180 degrees. So what we did, Gift, is we went 84 plus 38, and then whatever we got, we took that 180 minus that, and it gave us 58 degrees. Remember angles sum in triangle from grade 7? Good. Okay, so we know that this is bigger by a factor of 2. Right. So if this side over here is equal to 2, what is, if AB is equal to 2, what is MN going to equal to? That's it, Loken. This was pretty easy. Yeah, it's pretty easy. Oh no, Gift, you're gonna have to catch up. Should we sign you up for grade 7 also? We also have a grade 7 class, eh? Okay, great. So we get that MN will be equal to 6. Now, we don't have AC. We don't have AC. We have MO. If MO is 15, what is AC going to equal to, guys? That's it, Namani. Excellent. It's going to equal to 5. Good. All right. So we're happy about this. We're happy about this. There's nothing wrong here. We've got the right things going. Excellent. Now we're going to ignore this triangle. And we're going to talk about what's happening in this one over here. Wow. Now I'm not going to. That one was a bit too easy. You guys could see it. Now let's say in triangle MNO, and I need to make sure I get the order correct, and triangle QRS. Okay, I want you guys to tell me now at face value, well, as you're looking at it, how did we get from 12 to 13? I can already hear people scrambling for their calculators. Man, what happened? Where? Ooh, it's not times 3. Siposetu, did we have to grab our calculator to find that answer? It's a little bit more difficult when the sides aren't in an exact proportion that we can see. So we're gonna actually have to use the idea of ratios to get to the answer that we're looking for. All right, so this is what we're gonna do, guys. We're going to go, we know that MN and QR need to be in the same proportion. So I'm gonna go MN needs to be in proportion with QR. So I'm gonna write MN over QR, and that proportion must be the same on all the other sides, right? That must be equal to, let's say MO. Which side is in proportion to MO, guys? MO is in proportion to which side? Tell me in the chat. That's it, Namani, excellent, good. That's it, Liabona, well done, guys. So QX all the way to the end over there. So MO needs to be in proportion with Q. All right, okay. And this also needs to be in proportion with NO over which side? NO over what? Liabona, you are on the money. Akahang, that's it. Over RS. Okay, excellent. All right. So we can see that there's a proportion here. Now, I'm not going to use this last proportion because it's just going to mess up what we're looking for. I'm going to name my QR in this drawing. I'm going to name it X. I'm going to name it X for now. And then I'm going to replace all of these MNs and QRs with the numbers and that we have. So I know that MN is 6 over QR, which is X. And this is going to equal to MO, which is 15 over QS. Oh, that's not going to work. Okay, let's use the other one, not MO. Let's use NO. Yeah, because now I have two unknowns. NO over RS. Otherwise, I'm going to have two unknowns and I won't be able to solve it. So NO is 12 over RS, which is 30. Now I say to you guys, solve for X. How are we going to solve for X, guys? Solve for X. What can we do? Anybody got any ideas? Yeah, I love it. I love that. Whoever unmuted and said it, 100%. We're going to cross multiply. Cross multiply, and then we're going to solve for X. 30 times 6 will give me 180, which is equal to X times 12, which is 12X. Divide both sides by 12, as we always do. Divide to get X on its own. Divide by 12. Give me an answer, guys. X is equal to, therefore, X is equal to how much? Let me know.
15.
Beautiful. 15. Ah, nicely done. Good. X is equal to 15. Now we know that our X is equal to R is equal to 15. Now, Mani says, if we do not consider the triangle ABC, how do we know that MN is equal to 6? In this case, we've already calculated it, Namani. I'm going with the assumption that we've already been given the answer. Okay. I'm going with the idea that let's just say we know. It's not that I'm completely ignoring it. It's just that this comparison is a lot easier than that comparison. So I'm just like, let's not do all three of them together. Let's only work with two triangles. Okay. All right. So this is what we're going to do for QS. I want us to find QS, and we're going to name QSX. Does anybody want to put their hand up, venture for me, how we're going to figure out what QS is? Use the proportions of the sides in order to get there. Anyone? Anybody? Ooh, Pythagoras is not going to work here. We do not have we don't have a right angled triangle, but we're going to use our triangles, and we're going to use the proportions that we have. Does anybody want to venture which proportions we can use? The teacher Hugo, thank you. Only if we have a right angle triangle. What proportions do you guys think we can use to figure out what QS is? Okay, cool. So Siposetu says, let's go with MN over QR. And which two is that equal to? Remember, I want X in the mix here. I want X to be there as well. Okay. Tandikolo, does MN and QS go together? MN goes with QR. That's what we know for sure. What does QS go with? QS, the one that I'm looking for. It goes with MO. Good, it goes with MO. So I can say that proportion needs to be equal to MO over QS. And then we're just going to go in and we're going to replace what we have in our drawing with the numbers. MN is 6 over QR, which is 15. And this is equal to MO, which is 15 over QS, which is X. And then you guys already said it. We're going to cross multiply. So I want you to go ahead, guys, cross multiply for me and give me an answer. Give me an answer for X. I'm going to get here 6X is equal to 15 times 15, which is 2. All right, give me an answer for X, guys. Therefore, you know I love my therefores. Therefore, X is equal to what? Beautiful, Rita and Siposetu, that's it. 100%. It's equal to 37. Okay, well done. All right, let's see how comfortable everyone is with what has happened. Give me on a scale of 1 to 10, you know, 1 being no ma'am, and 10 being 100% ma'am, I'm with you. Tell me how are we feeling in the chat. Hannah says, I've done mine differently, but got the same answer. Did you use the same proportions, but with the different sides, Hannah? Is that what you did? Because if you use the other sides and you got the same answer, you are 100% spot on. I'm sorry. See, it's going to work either way. It doesn't matter which side we use, as long as we use the correct side, Hannah. All right, well done. Excellent work. All right, I'm seeing a couple of 9s, 7s, 6s, which is fine, guys. It's something that we're going to get used to as we go. Tiana is not make sure. No, oh no, my sweetie. It's okay. We're going to get there. We're going to get there. Don't stress. Okay, we now have to learn how to prove, guys. You know me and we must. Okay, so we know that when we are proving for similar triangles, we're going to try and prove two things. We're either going to try and prove that our angles are equal. So we're going to use A, or we're going to try and prove that our sides are in proportion. Sides in proportion. So that's what we say. That's what tells us that we have a similar triangle. Okay. Now it says here to us. Remember, we're going to read the information they've given to us. It says, prove that triangle ABC is similar to triangle ADE, and pay close attention to the order, guys. If BC is parallel to DE. As soon as we see parallel, we already know where we are going. Yes? Oh, CK, it was 37,5. Okay, yes, Patty.
Ma'am, angle A is common.
Beautiful. Okay, we're gonna get there. I think she
Oh,
jumped
okay.
the gun, no, don't go away. Yes, you're right. Angle A is covered. I think you jumped the gun. You're 100%. All right, but we still need to map out our triangles. Thank you, Pachi. Pachi's trying to steal my job. They just jumping all the way to the end. All right, we're gonna map our triangles out, guys, just to make sure that we've got the correct thing. All right. Thank you, Tiana. Tiana's remembered that this is our fun angles. We need to remember that. Right. So in triangle, remember we're proving. So prove in triangle ABC and triangle ADE. We're going to map them out. ABC triangle and triangle ADE. Close. Okay. We need to see what these actually have in common, right? Okay, or what we can say. Right, so Katya has already told us that angle A is common. Angle A is common, and she's correct, it's common because they both have angle A, angle A. Now, the two things that we still need to prove here is what angle B is equal to, what angle C is equal to, okay? Liabona says BC is equal to DE. No, it's not. Why do I say no, it's not? What do arrows mean, Leon? Do arrows mean equal? No, arrows do not mean equal. What do arrows mean? They mean parallel. That's it, Nabil. They mean parallel. So we can't just go ahead and be like, because they're parallel, they are automatically equal. Siposetu is also saying AB is equal to AC. No, they haven't told us that. Okay, so what we need to work here, what we need to work with here is the angles that they've given us. Okay.
B1 plus B2 is equals to C1 and C2.
Okay, yes, you're correct because they're both angles on a straight line, but that's not going to help us, must be. Okay. Okay. B2 is equal to C2. I don't agree with you, Namane. I don't agree with you. Okay, let's look for an F or a U or an N. Yes, David, absolutely. Corresponding angles. Okay, I'm going to draw an upside down F for you guys. Yeah. Here's my upside down F. Because I know that this line and this line are parallel. If we look at these two angles are equal to each other. If and Mercedes, none of the sides are going to be equal to each other. They haven't told us that. Let's look at our F. Which two angles are going to be equal to each other?
Ma'am, angle D and angle B1.
Beautiful. That's it. B1 and D are going to be equal to each other. What is my reason for that?
Ma'am, corresponding angles.
Beautiful. That's it. The F, which is corresponding angles. Corresponding angles. And then I need to name which of them are equal or which lines are parallel. I have to say BC is parallel to DE. That's part of mine. Right. And then there we go. Now everybody's getting it. There we go. Okay, cool. I see now that Hannah has seen it. C1 is equal to D. That's it. C1, or let's start with, not D, sorry, E. Then angle E is equal to angle C1. Okay, and for the exact same reason, I'm just going to draw my F in the opposite direction. Here's my F. This angle and this one will be equal to each other. So E will be equal to C1, and that's corresponding angles. And again, my parallel lines, BC is parallel to DE. And I can make my conclusion. I can go, therefore, triangle ABC is equal to, oh, don't equal, my life is similar to 1, 2, 3, triangle A. Okay, now we have just proven that, and we just need to write here that our reason for this was we proved that an angle is equal, we proved that an angle is equal, and we proved that an angle is equal. So our reason is a angle, angle, angle. Sequoia says, can't we use alternate angles? We will have to find a Z, my sweetie. Okay, where is our Z? Let's try and look for a Z. No, that doesn't help me because it doesn't incorporate both of my parallel lines. I can't find the only way we would be able to use alternate angles is like this. There's no line here. Okay, so we can't use alternate angles. All right, we can only use alternate angles if that thing there in the middle. All right, so the thing we need to note, guys, is if we can prove that angle, 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 if the angles are equal, that automatically tells us that the sides are in proportion. Now, I'm going to look at this triangle again, guys. I'm going to write it down again, just so we remember. Okay, triangle AB. Give me 1 second, Rita, I'm going to be with you. Triangle ABC is similar triangle ABE. Yes, my sweetie.
Ma'am, this is kind of a dumb question, but
There's no
if
dumb question.
hypothetically we try to say, therefore triangle ABC is similar to triangle ADE, blah, 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 but we confuse the congruent and similar signs, would we get it wrong if we put the wrong sign? Like the lines are sometimes confusing.
I know. It's just, South Africa just doesn't use the different symbol for congruency, because the congruency is actually, you can write it like that with a little squiggly line over it. You can even write just a squiggly. But unfortunately, the South African curriculum says that you need to use the 3 lines. But I think if you write in your test or exam, if you write this symbol for congruency instead of the other one, your brain might remember it easily, and they'll be forced to give you a mark because math is a universal language. Okay, and this, they know, because your math teachers know exactly what this is. So maybe learn this one for congruency. Okay.
Yes, ma'am.
All right. Okay, so we know that if our angles are equal, then our sides are automatically in proportion. So we can use our triangle. We know that side AB will be in proportion to which other side, guys? In this triangle. Side AB will be in proportion with which side? Let me know. Good, with AD. Excellent. Good. AB is in proportion with AD. So I can go AB is in proportion with AD. And then I also know that BC is going to be in proportion with what? This is going to be the equal to BC in proportion with? Good, David, 100% with DE. That's it, Runabile. That's it, Christina. DE, good. Okay, and that gives me the last 2. AC will be in proportion with which one? AC will be in proportion with? Good, with AE. All right, with AE. Right, now they say to us, if AB is equal to 6 centimeters, so we know that AB over here is 6, and AD, so from here to there is 8, so from here to there, that's 8 centimeters, and AC is equal to 9 centimeters. Calculate the length of AE. Right, so we want to find AE. So here's what we're going to do, guys. We're going to take the information that they've given us, and we're going to use it to our advantage. Yes, this is given information. Here it is. Here it is here. Like, is it given here? It's given over here. We're going to use the information they've given us, guys, and we're going to make sure that we're using it correctly. So they want us to find AE. So I'm immediately going to go to the proportion that has AE in it. I'm going to go here. AE. So I'm going to be using the proportion with AC and AE. Can you guys find another proportion between these two where the information has been given to us? What other proportion can we use to prove this or to find it? Ah, that's it, Zamanzini, 100%. Good. We can use AB over AD because they've given us the answer, the values for AB and AD. So for now, we're not going to use this middle one because it's not going to help us. So we're going to go AB over AD is equal to AC over AE. And remember to stay muted, guys. Okay, remember to stay muted. All right, then we can go AB is equal to 6. They've given us that 6. AD is equal to 8 is equal to AC, which is 9 over AE. And then how do we solve for AE, guys? What are we going to do? Just cross multiply and give me an answer for AE. Good, gift. We're going to cross. So I'm going to end up with 6 AE is equal to 9 times 8, which is 72. Therefore, Tiana's already beat us to the answer. Therefore, AE is equal to 12. Excellent. AE all the way from there to there. All right. Scale of 1 to 10, how are we feeling? Let me know. Scale of 1 to 10, how are we feeling about proving? Siposetu is at a 10. I love it. Okay, Hannah's at a 15. Loving it. Nice one, nice one, nice one. Okay, Loken is at an 8. Samanzini at a 10. Hatu also at a 10. Okay, 1 mil. Tiana, it's make sure. We see it now. We see it. I love how at the beginning of every class, you're like, it's not make sure. And at the end of the class, you're like, it's make sure. I love it. All right. I'm so glad we're happy, guys. If you're still at like an 8 or something, I'm going to give you a challenge. Okay. Oh, I love it. I love it. It's your weaknesses becomes your strength because you're putting in the work, Tandipolo. That's why. Putting in the work. All right. I'm going to drop this. Okay, this is what happened. Thank you. I'm going to put this on the screen while Teacher Hugo puts the link to the quiz on the screen. I want you guys to take this and go and prove similarity. Okay. Take a screenshot, everyone. This is where we're going to start. This is where we're going to start on Monday. We're going to do a quick recap of this, and then we're going to jump straight into quadrilaterals on Monday.